Let's take a look. So let's take a look at the following example in which we want to calculate the number of fundamental fermions inside a single carbon dioxide molecule. So the first question is, what types of particles are found inside our carbon dioxide? So the carbon dioxide basically consists of a single carbon atom and two oxygen atoms that are bonded to the carbon like so. So we have three different atomic nuclei. Now in each one of the nuclei we have protons and neutrons. The question is a proton or a neutron a fundamental fermion? Now a fundamental fermion is basically a particle that is said to have no internal net structure and which has a spin equaling to half an integer value. So the fundamental means it has no internal structure. The fermion part means it has a spin that is equal to half an integer. Now, protons and neutrons are not fundamental particles. In fact, they consist of fundamental particles known as quarks. And each proton and each neutron contains a triplet of quarks. It contains 3 quarks each. So to calculate the total number of fundamental fermions that are found in the protons and neutrons, we find the total number of nucleons and we multiply that by 3. Now we also have electrons, and electrons happen to be fundamental fermions. So once we find the total number of nucleons and multiply that by 3, we then sum up the number of electrons and that will give us the total number of fundamental fermions. So, let's begin with the carbon. The carbon itself consists of 12 nucleons. We have 6 protons and 6 neutrons, which sum up to 12. And we also have 6 electrons because this is neutral. So if we have 6 protons, we have 6 electrons. Now, what about the oxygen? Well, in a single oxygen, we have 8 protons and 8 neutrons, so we have 16 nucleons. We take the sum of the protons and neutrons, and because we have 8 protons, we have 8 electrons. Now, because we have 2 oxygens, we have to multiply this by 2, and this gives us 32 nucleons and 16 electrons inside those 2 oxygen atoms. Now, what is the number of quarks that we have inside our nucleons? Well, how many nucleons do we have to begin with? We have 12 nucleons and we have 32 nucleons. 12 plus 32 gives us 44 nucleons. Now we have 44 nucleons, but 3 quarks are found in a single nucleon. So to find the total number of quarks, one form of a fundamental particle, we simply take 3 multiplied by 44 nucleons, the total number of nucleons. So 12 plus 32 gives us 44, and this gives us 132 quarks. So because electrons are also fundamental particles and we have 6 plus 16 or 22 electrons, to find the total number of fundamental fermions, we take 22 electrons, we add that to 132 quarks, and that gives us 154 fundamental fermions. And we are done.